Hi, Aditi. So we're going to work on this problem we started to look at on Tuesday. Hang on a second. Okay, so we have that bonus problem. They're going to work on algebraically without guessing. So we know that two of the zeros are, oops, good. So we have k and 2k are two of the zeros, and let's just call the third zero m. And then we know then the three factors are x minus k, x minus 2k, and x minus m. And we're not going to multiply all those out for now because we don't need to. Let's just take a look at the leading term. If we did multiply them all out, would be an x cubed, just like our function gives us. We're just going to look at the trailing term, which we see in the function is negative 90. Let's look at what it is in our little expression here, because we know that three roots are k, 2k, and m. So these are the three factors. So in fact, the final term is, let me get a different color here, negative k times negative 2k times negative m, which is negative 2mk squared. And that has to equal negative 90. So we divide each side by negative 2, we get mk squared equals 45. We factor 45, and that is 3 times 3 times 5. So we see that k squared has to equal 9, but we are not allowed to guess. K can be either 3 or negative 3, and we don't know which. We're not going to guess because this problem says do not guess and check, so we're not. We know that k squared is 9, so we know that m does have to equal 5. And that, we know, is one of the roots, m equals 5. So we're actually going to do, if m equals 5 is one of the roots, then one of the factors is x minus 5. And that's for sure. But what we're going to do is we're going to do synthetic division around the root m equals 5 to find out what the remaining quadratic is if we divide this polynomial by x minus 5. But we're going to do it with synthetic division, so we have 5 into 1, 4, 9k, and then negative 90. So we have the 1, 5 times 1 is 5, 4 plus 5 is 9, 5 times 9 is 45, 45 plus 9k is actually 9k plus 45. And, oops, 45. Now 5 times that is 45, oops. $45k plus 225. And then we add these together, we get 45. I did it again. $45k. 225 minus 90 is 135. That's the remainder. And we know that that remainder has to equal 0. Because in fact, these three factors, x minus k, x minus 2k, and x minus m, multiply together to exactly equal that function. There's no remainder involved. So 45k plus 135 equals 0. 45k equals negative 135. K equals negative 3. 2k equals negative 6, and m equals 5. And those are, in fact, the 3 zeros. Now, just to check, we're going to actually, let me erase this. You can always go back in the video and see what we did. We use a little sort of math logic to know that the final term of our generalized expression would be negative 2mk squared, and that has to equal negative 90. And from that, we can know for sure that m equals 5. Then with a little synthetic division, you can do that with polynomial long division also, we find that k has to be negative 3, and therefore 2k is negative 6. And those are the 3 roots. And now we are going to multiply out, just for a check, we're going to multiply out x plus 3 times x plus 6 times x minus 5. So x plus 3 times x plus 6 is x squared plus 9x plus 18. Going to multiply that times x minus 5. We get x cubed plus 9x squared plus 18x minus 5x squared minus 45x minus 90. We see our x cubed and we see our negative 90. They match up. Look at this, 9kx. Well, we found out that k is negative 3, so 9kx is negative 27x. Let's check that out. 18x minus 45x is, in fact, negative 27x, so that's good. And 9x squared minus 5x squared is indeed 4x squared. So that is how we found the 3 zeros without guessing and checking. We found it in a straightforward way, and then we just checked our answer by multiplying out those 3 binomials, x plus 3, x plus 6 times x minus 5, and we found that indeed, substituting negative 3 for k in this original function, we do get that x cubed plus 4x squared was 9kx minus 90, and so it all checks. So I'm going to get this over to you, and I will see you later.